Hi, Lynn again. This lesson is on complex numbers, otherwise known as imaginary numbers. And before I talk about this, I wanted to show you one of my favorite Calvin and Hobbes cartoons, kind of a math joke, but here it is. So I will let you read that. My favorite part is what Hobbes says. So let you read that and then we'll get back to math. All right, I'm back. Now we can do math. I think that's very funny. Um, but then again, I'm kind of a math nerd, so that's okay. Anyway, right now, remember I've talked about math gods before, and they make up rules, and some of the rules are you can't divide by zero, which is okay. Some of their silly rules is you can't have a radical or a square root in a denominator, and I think that's kind of a silly one because you get a number. One of the other rules they have is you can't divide by you can't have a negative under a square root until today. Today, you now can have a negative under square root because I, imaginary number I, is equal to the square root of -1. We're defining it now. So now you can take the square root of -1 and it turns into I. So whenever you see a negative under a square root, my tip is I just sort of picture that negative coming out to the outside and becoming an I. So this one would turn into just I times the square root of 20. Now you're not done with that. You need to get everything out of jail. So this is going to be I times the square root of 2 times 2 times 5, or if you recognize it, it's 4 times 5. So these two twos are friends and they can get out of jail. So this would be 2I times the square root of 5. So that negative inside does not make the whole thing negative. If it's inside a square root, it comes out, boom, and becomes an I on the outside. So the next part of this section is we're going to be adding and subtracting and things like that. So you treat I just like a variable. Just like a variable, like x, with one exception. The exception is when we square it. So if we have I squared, remember we square both sides, what will I squared be? I squared is now equal to -1. And that is really the main difference you have, especially like if you're foiling or something like that. So that will be this example right here. This is going to be a foiling example. But let's look at the subtraction example. Subtraction, I just put in here to save time. Addition is the same thing. So what we really need to do is just combine like terms. So, but with subtraction, you need to make sure that you distribute that negative sign. So this is going to be 4I minus 3 plus I. So if this was 4x minus 3 plus x, you would just combine the x's, so that's what you do with the I. So this is going to be 5I minus 3. Now one of the things they also talk about it is put it in standard form, which is A plus BI form. This is the real part of the number, and this is the imaginary part of the number. Together they make up complex numbers, because complex is real and imaginary combined. So we need to put the -3 first, because that's the real part, and then plus 5I, and that would be the correct answer. So pay attention to that on the test. It needs to be in the right order. All right, so these are the two examples. One more example we're going to do right now is multiplying. And so we're going to go first, 2 times 4 is 8 for the foiling. Outside is plus 2I. The inside is minus 20I. And the last one is minus 5I squared. and I write it as I squared. I don't try to do things in my head. Then you like forget, wait, did I change the sign on that or not? Because I squared we know is -1. So it'd be -5 times -1, which just changes the sign. So what I like to do is say, okay, I'm taking care of it right now and changing that sign to plus. So write it as I squared and then change the sign. So now the 8 and the 5 are like terms. So this will be 13, which is the real part, which goes first. The imaginary part is going to be minus 18i. That's in standard form. And so that's our final answer. Right, so now I'm back on the whole new board, aren't I fancy? So now this is one more example, but I really want you to notice what this is. This is 7 plus 3i and 7 minus 3i. That's like the difference of squares factoring. What happens when we multiply these two together, the middle term drops out. This is called, these are called conjugates. Oops, I need to spell it right. Conjugates. That's a very important word. Very well might be on your test. It's because what happens when you multiply them together, the I or the square root will be eliminated. So if we FOIL this, 7 times 7 is 49. And then we have the inside, or the outside is minus 21i. The inside is plus 21i. And then the last would be minus 9i squared. So this I squared is just -1, so I can cross it out and change that sign to plus 9. So it's 49 plus 9, which is 58. And plus 21i and minus 21i add to 0, so they're eliminated. So our final answer is just 58. The shortcut would just be 7 squared plus 3 squared, or 49 plus 9. So that's very important when it comes to dividing. So remember the math gods, they sit out there and they say no square roots in the denominator. So the denominator, by having an I in it, has a square root in it. So notice the way we got rid of the I was by multiplying by the conjugate. So what is the conjugate of 3 plus I? The conjugate is where everything matches except for the sign in the middle changes. So it would be 3 minus I. And to balance it out, we need to multiply by 3 minus I in the numerator. And then just to clarify things, I like to put parentheses around the first thing. So this we have to FOIL. So it would be 4 times 3, which is 12. 4 times -1, negative I is minus 4i. And then it would be minus 3i. And then plus I squared, because it was a negative times a negative. So what this turns in is 2 minus 1. So we have 12 and then just in the bottom we have 9, and then plus 3i minus 3i is 0, and then it's minus I squared, so which is plus 1. So this whole thing is going to be over 10, and so this is going to be 12 minus 1, which is 11, and this is minus 12i over 10. Now a good thing for you to do is to write this, to see if it can be reduced, write this as separate denominators. So we can write this as 11 over 10 and 12i over 10. So we have 11 over 10, which can't be reduced, but 12i over 10 can. So it'd be minus 6i over 5. That's the real part and the imaginary part. So that would be the final answer for this one. So that's dividing. Dividing is the hardest part. Remember the word conjugate. The way you get rid of the square root in the denominator is by multiplying by the conjugate. Before we just filled out jail. The way to fill out jail when there's two terms like this is to multiply by the conjugate. So now I'm going to look at this I to a certain power, and I want you to notice this pattern. If we have I, that's just equal to I. If we have I squared, we know that's equal to -1. If we have I to the third, That means a negative 1 times another I, so that equals negative I. And if we have I to the fourth, it's negative I times another I, so it'd be negative I squared, which is positive 1. So that means I to the fifth starts over again with I to the sixth is negative 1, I to the seventh is negative I, and I to the eighth is 1. Once it's 1, it starts over again. So there's these first 4 and then these second 4. So when you have something like I to the 14th, you know that every group of 4 gets back to 1. So this would be like I to the 12th times I to the second. I to the 12th we know is 1 because it's a multiple of 4, and I squared is going to be negative 1. So this whole thing would just be negative 1, or just what the leftover is after you divide that by 4. So we could even do like I to the 102nd power. On 102nd, 4 goes into 100 evenly, and there's 2 left over. So that would also equal negative 1 because that's I squared. So that's covering all the little bit harder parts. Enjoy the cartoon, share it with your friends, practice this, notice these patterns, remember the word conjugate, and we'll see you next time.